So now let's look at the example. Okay, before that we will list the steps that we use to draw a sketch of a higher order polynomial graph, that means degrees 3 and onwards. Okay, so in the beginning also we discussed that these graphs we show the important properties. So some properties are related to that graph type and some are general. Okay, so we said that x and y intercepts are general. Okay, so we will always find this x and y intercepts. Okay, so normally we will start by factorizing. If possible, we will factorize the polynomial using the general factoring techniques. Okay, you studied in algebra 1 and also you saw in some of these previous examples. Then we will find the x-intercept. You already know how to find x-intercept. You will set y to 0. Actually, you will get an equation. Okay, so this equation may depend on the type of the polynomial. Now if it's degree 3, you will get a cubic equation. Degree 4, you will get a degree 4 equation. So you learn how to solve these in previous examples, how to solve these equations. So you can use general factoring techniques, or you can use that synthetic division and rational roots theorem approach. Okay, then you find the y-intercept. That is simple. You plugging in x0, so usually that is the constant term. Then we find the excluded regions. Okay, I'll show you how to find them. I explained what is excluded region in previous video. So we'll find them. Then the behavior at the endpoints. Okay, then we discussed that also. So if it's even, they will look like x squared, and if it's odd, they will follow x cube. Endpoints behavior at the large x. Okay, and then also the number of turning points may be helpful, so to spot a mistake. So if you draw a degree 3 graph and if you have 3 turning points, that means you are doing a mistake. You have made some mistake. Okay, let's jump into the example. So I have to draw a sketch of this graph. Okay, so first I will try to factor this if possible. Okay, so fx, so if you look at here, they don't have any common factors, but you can see we can use the factor by grouping method. So if you look at these two here, you have a common factor x, and these two here you have a common factor 2. Okay, so here I pull out the common factor x, you will get x squared plus 3. Here you pull out the common factor 2. Sorry, here actually I can pull out a common factor x squared. Okay, so x squared is common here. So I pull out x squared. So if I pull out x squared, okay, so you pull out x squared, what is left? X, because you have 3 x's, 1 x is left. And then you have 3x squared, I pull out x squared, so x plus 3. And what is common for these two? 2 is common, so I can pull out 2. So if I pull out 2 from this thing, I have x, and then you have plus 3. Okay, so now if I look at here, x plus 3 is common, so I'll pull out the x plus 3. Okay, so I pull out the x plus 3, what is left? X squared plus 2. Okay, so this is, you have this thing left. Okay, now we will go to the next step. We need to find the x-intercepts. Okay, so to find the x-intercept, you set this to 0. X plus 3 and x squared plus 2, the x-intercept, you have to set this equation to 0 actually. Okay, so this is a cubic equation. Okay, so actually I can start by setting this to 0. 3x squared plus 2x plus 6 equals to 0. You get a cubic equation there, no? So when you try to find the x-intercept, I have to set y 0, no? For the x-intercept, y is 0. So you set y to 0, so you get x cubed plus 3x squared plus 2x plus 6 equals 0. So then to solve this equation, if I can do the factoring, I can use the factoring techniques, no? So this is generally you can factor. Actually we did the factoring in first step, so we can use that factored thing here. Okay, x plus 3 and x squared plus 2, then you can set each factor to 0. Okay, so this is x equals negative 3 and x squared equals to negative 2 and x plus or minus square root negative 2. No, that means a complex. So for the graphs, we are not considering complex roots, okay, because we draw the graphs only using real roots. So here I got only one x value, no, x negative 3. Actually I get 3 values, but 2 of them I will not consider them as x-intercepts, okay, because we draw using real numbers. So the x-intercept, this thing was given by y0, no? So negative 3x and y0, I get only one x-intercept because these two are complex numbers. Okay, so I have the x-intercept here. Okay, so then I'll find the y-intercepts. So the y-intercepts here. Okay, so for the y-intercepts, I can set x0 here, no, or plugging in x0. So if you plugging in x0, all these terms become 0 and you will get these terms 0, no? Actually that answer will be the constant value, no? And 2 0 plus 6. So directly you can take y-intercept is y value of the intercept is 6. So this was given by x0, so you get 0 6. Okay, so now I know x-intercepts and y-intercepts. I will go to the next step. So next step is finding the excluded regions. Okay, finding the excluded regions. Okay, finding the excluded regions. So to find the excluded region, I explain what are those. So we'll use this x-intercept, no, because it depends on the x-intercept. Okay, so I will explain this step. Okay, this is little bit tedious step, not very but little. Okay, it involves few steps. So this method, you start by first you will draw a number line, then you mark the x coordinate of the x-intercept. Okay, so what was the x coordinate for the x-intercept? The x-intercept is negative 3. So in this number line I have only one value, no, x equals negative 3. You can easily mark that x equals negative 3. Okay, this x-intercept will divide the graphs into intervals. Okay, when you mark the x-intercepts, it's going to divide the graphs into intervals. Okay, this number line into intervals. So here only one x-intercept, so I will get 2 intervals. Okay, so now if the graph is positive, let's say in this region for one value, it have to stay positive, no, because it's continuous, it cannot become negative without going through 3. So if it's positive, it will get stuck in the positive. So this region, so I will need to find what happens to the graph in each of this interval. So what happened to the graph in each interval is represented by just any value in here. Okay, so to check that, I can pick a test value, okay, from each interval. So this interval is what? Less than -3, -3 to infinity. This interval bigger than -3, -3 to positive infinity. So I can pick any value from here and check the graph. Okay, when I check graph is the y coordinate for that value. So I can pick a test value from here. I will pick the test value to be something less than -3. I can pick -4 or -5. No, I pick the smallest possible value, integer value, so it's easier to plugging in. Okay, so now I know this x -4. For that value I have to check what is the y. Okay, so the y for this value is always, I know x coordinate -4, the test value I pick, corresponding y I have to go through the equation. No, so what is the equation of the graph we are drawing? Okay, this is the equation. No, so to find the y coordinate at the test value x equals -4, I will plug -4 here. Okay, so when you are plugging in, it's easier to use the factored form. Okay, because factored form is same as this thing. So the factored form, what we got, x plus 3 and x squared plus 2. No, so it's easier to actually plug into this one than this one. Okay, you will get the same answer. So I will plug into the factored form. Okay, so that is -4 plus 3, x squared is what, 4, sorry, -4 squared plus 2. Okay, actually we are interested in the sign here. Okay, so here I get a -1, here -4 squared is positive 16 plus 2, no, 18. So I get a -18. Okay, so actually I am interested in the sign here. So in this region graph stays negative. No, so in this region graph says negative. So this 4, it's negative, so all these interval graph have to say negative, because it cannot jump to positive, because only available x-intercept here. No, so this region becomes excluded. Okay, so because graph stays in this, so above this x-axis excluded, graphs will stay along in this region. Okay, now for the other region again I have to pick a value. Okay, so the other region, so bigger than -3, I need to what happens. So graph will stay negative here. Here it will become 0. Now it has two options. It can go up, or again it can go down. Okay, if it's turned like a parabola, maybe it can go down. No, otherwise it can go like x cube, maybe go up. Okay, so we can see here actually that x cube thing also we can use to that, see that is go up, but also we'll use the general method. Okay, so we'll plugging in a value. Okay, test value. So I will pick another test value. So I need to pick another test value from this interval. I can pick any value bigger than -3. Okay, so I will pick 0, because 0 is bigger than -3, because it's easy to plugging in. No, so I will plug in 0 and see what is the y value. Okay, so fx, actually here if I plugging in 0, that is actually the y coordinate. No, sorry, to 6. No, so it's a positive value. Okay, so this region graph stays positive. This region graph stays positive, so it will not go into the excluded region below. Negative area it will not go. Okay, so the negative area is the excluded. Okay, so let us retrace the steps. Okay, so first what you do, you mark the x-intercept, then you look at the intervals generated by this x-intercept. No? So here there is only one x-intercept, that will give you two intervals. So from each interval you pick a value. So this -3 to infinity, -4 is inside this interval. You pick that x value, okay, x coordinate, then you plug in that to get the corresponding y, no? Because if you know x, to get y always you go through the function, okay. Then if y is negative here, that means graph will get stuck in the negative region y value, negative y values. That means graph will stay below the x-axis in this region, okay, and graph will roam around this region, and above the x-axis becomes excluded for him. And for this interval also you pick a test value, okay, you can pick any value. We pick 0, we plugging in, I got positive. That means graph will become positive and roam around the positive values here, and this becomes excluded. Okay, so now we'll go for next one, analyze the behavior of the large positive values of x. So the large positive values of x, this is cubic, no? So it will behave like x cube. So that's why I said it's important to remember x cube. So x cubes look like this, okay. So the graph, it's an odd power, no, x cube. So the large x value, your graph will behave like this, no, okay. Now that number of turning points we will check at the end to check the correctness, okay. Now we can go ahead and draw the graphs, okay. So when you draw the graph, first we mark the x-intercept, excluded regions and y-intercept, and then endpoints, and then connect the graph, okay. So here I will set the axes depending on the values I have. So for the x-intercept, this is x and y, okay. And for the x-intercept I have -3, I will mark it here, and then y I have 6, no. So the x-intercept here, x-intercept is here and y-intercept is here, no, 0, 6 and 0, 3, okay. So next we will mark the excluded regions, okay. Excluded region, I have this interval below and above, no. So the below the interval excluded region is this black region, okay. So the graph will not go in the black region, okay. And then after -3, the excluded region was below, no, because here it was negative and here positive, the x region is here, no. So that graph does not go in that region, okay. You don't have to black out them, but it's good if you black out them, so you know graph will not go there, you will not make any mistakes, okay. So actually this 3 I mark little bit above too, no, if I keep it the same thing, 3 is somewhere around here, okay. So I should have it, okay. So 6 actually I put it little below if I keep the same scale, okay. So now the behavior of the end, no, so it look like x cube, so it have this behavior. So here it will go down, and this region it will go up, okay. Now what is left is to connect these points, okay. So here the graph will come here, see this, okay, and then now graph will have this shape, okay. So this one didn't have that turning point, okay. It's fine, okay. It's with have more than 3, then is a problem, okay. So we got this shape, okay. So when you learn calculus, you will learn more things to uh, uh, get the shape of the graph a little bit further better. Okay, actually you can make it a lot better if you use calculus, but this is just a start. Okay, so after you practice with this technique, you can skip some steps also. Okay, but in the beginning it's better to use the whole step, but depending on the graph, when you have more experience, you can start skipping some steps. Okay.